I'm Genesis.
And I'm Sage.
And we're going to learn some physics today.
But first,
there's safety rules. We're just going to put on our lab coats and our safety goggles.
whoa! These aren't our goggles.
My bad, I must have grabbed the wrong pair.
Oh.
That's
better.
This is more like it.
We're going to be doing the collision lab today. The learning objectives, students will be able to understand the law of conservation of momentum and will be able to explain the concept of momentum.
The second objective is that students will be able to solve both elastic and inelastic collision problems and understand the difference. So the first thing you want to make sure you do is that you check off the velocity vectors one and you hit reset all. So the only thing that should be checked off is the momentum vectors. Nothing else.
Make sure elasticity is 200%. So this is an elastic problem. So what we're going to do is just press play and pause it. As you can see, the objects collide and then they separate. They do not stick together. This also, just notice that in the beginning, this arrow right here is of momentum, and object 2 does not have momentum because it is at rest, and momentum is mass times velocity. So if velocity is 0, then there would be no momentum. So when they hit, the object 2 starts to move, and some of the momentum is put onto the second object. And
something that you want to take note of is the mass. So the mass is given to you right here, and you're going to need this when you solve the problems. For example, like when we ask you in your in your handout, when we ask you to solve for the momentum of ball 1 before the collision, you're going to need the mass of ball 1 and the velocity of ball 1, which we give to you is 1 meter per second. So now you're going to want to look at your pre-lab and look at number 11, and it says, what is the law of conservation of mass? And so I'm sure last year you learned that mass is always conserved, and so there's a similar thing with momentum. Momentum is always conserved in inelastic and elastic collisions, and if you look at your worksheet, it says the symbol for momentum is P. So the equation is P before equals P after, and when you expand it, it's MA times VIA plus MB times VIB equals MA times VFA plus MB times VFB.
So in our worksheet, we ask to find the momentum of ball 1 before the collision. And since, like we mentioned before, momentum is the symbol for P, which is mass times velocity, you would do the given velocity of number 1, which is 1 meter per second squared, 1 meter per second, sorry, and the mass, which is 0.5 seconds. And so you would get the answer to that problem. Then we'll switch over to the inelastic type of equation. So all you need to do is just move this down to 0. You can press restart, and we'll press play again.
And now, as you can see in this one, the objects stick together, so there's a difference with an inelastic collision.
If you think about, like, what do you think elasticity actually means, then, which is a question in our handout, so we're not going to tell you, but just notice that in an elastic equation, the objects do not stick together, and in an inelastic equation, the objects do. So right now, the masses
are combined, so then your equation would be just a little bit different. The second half would actually be you adding the mass of the first object and the second object to get an overall mass, and then just the final velocity. And so one of our questions asks to solve for the final velocity of both objects because they now become 1. And you can do that by just plugging in the problems. As you can see, the mass is given for you. We give you the initial velocity of object 1.
And object 2 is at rest, so the velocity would be 0. So then you just plug in and solve. Also, when you are solving for each object's momentum at the end of the equation, you have to make sure that you're doing the mass, but the actual mass that is given and not the combined mass. So what you would do is the velocity with the objects together times the mass of the certain object.
And you want to make sure to always respect signs because momentum and velocity are vectors, meaning they have both magnitude and direction, and therefore you must respect signs.
And the direction of an object in motion is always the direction of the net force, which is one of the questions in the lab plan. So that's about it for collision, the elastic and inelastic equations.
And hopefully after your observations, you're able to fill out the chart at the bottom, which should be easy to do.
There's no, like, exact things that you can put in the table. It's kind of just an overall answer to all of the things you learned in the video. Okay, thank you.